we'll now look at the limit of a sequence. So if the terms of a sequence approach some unique number L as n increases, then we say the limit as n goes to infinity of our sequence L exists, and that it converges to L. And if the terms do not approach a single number, then it has no limit, and we say it diverges. So for example, let's consider this one. I want to look at the first four terms, and then we're going to make a conjecture about its limit. So when n is equal to 1, I have negative 1 to the n, or negative 1 to the 1, over 1 squared plus 3, which was negative 1 over 4. As n is equal to 2, negative 1 squared, over 2 squared plus 3, which is negative 1 over 7. As n is equal to 3, I have negative 1 squared over 3 squared plus 3, or negative 1 cubed, and this is positive, which is negative 1 over 12. And for n equal to 4, negative 1 to the 4th, over 4 squared plus 3. So negative 1 to the 4th is positive, over 16 plus 3, which is 19. So for the limit, we can see that this does alternate between positive and negative. Negative 1/4, positive 1 over 7, negative 1 over 12, positive 1 over 19. However, both of these positive and negative numbers are approaching 0. So we're going to conjecture that this limit is 0. Next, let's consider this one. For n equal to 1, I have sine of pi over 2, which is 1. For n equal to 2, I have sine of pi, which is 0. For n equal to 3, sine of 3 pi over 2, which is negative 1. And for n equal to 4, sine of 2 pi, which is 0. So this one is going to diverge, mainly because we can see this oscillating. So basically, we see the 1, 0, negative 1, 0. If we continue, we'll repeat this pattern, 1, 0, negative 1, 0, etc. So this one is going to oscillate forever, so it diverges. Next, we'll look at a series. So if we have a set of numbers, the sum, a1 plus a2 plus a3 plus a4, etc., is called the infinite series, and this is given by the summation notation of a sub k. And it's the sequence of partial sums. So the sequence of partial sums has the terms s1 is a1, s2 is a1 plus a2, s3 is a1 plus a2 plus a3, etc. So let's do some examples with these. First, if the sequence of partial sums has a limit, the infinite series converges to that limit. And if the sequence of partial sums diverges, the infinite series will also diverge. So let's consider this infinite series. Each term is the sum of 1/10 of the sum is 1/10 of the previous term. So I want to find the sum of the first 1, 2, 3, 4, and 5 terms. So for 1, that's just 0.9. 2 is going to be 0.9 plus 0.009, which is going to be 0.99. 3 terms, now I'm considering all 3 of these, 0.999. 4 terms, I'm going to add in this extra term, 0.9999. And we can follow this pattern to get the 5th term, which is going to be 5 nines. So now let's see, what value would we assign to the infinite series? Well, we saw the pattern that was 0.9, 0.99, 0.999, 0.9999, and we can see that this continues, and that these numbers are getting closer and closer to 1. So we would assign the infinite series the value of 1. Next, let's consider this one. Let's find the first four terms of the sequence of partial sums. So the first one is just the first case. 1 over 1 squared plus 1, which is 1 over 2. The second case is now 1 over 2 plus sticking in 2, which would be 1 over 5. The third one, I now have 1 over 2 plus 1 over 5 plus, when I stick in 3, I get 1 over 10. The fourth one, 1/2 plus 1/5 plus 1/10, and when I stick in 4, I get 1 over 16 plus 1, which is 17. Adding these up, this gives me 7 over 10. This is 8 over 10. And then this last one is 73 over 85. If we want to make a conjecture about the value, we're going to conjecture that this is once again 1, because we saw that all of these values are definitely going to be fractions. However, they do get progressively larger and larger.